Hello, everybody. I found myself journaling in the last couple of days. As you can see here, I have a journal where I ask myself questions and I answer them. And I thought, why do I even do all of this on paper? I mean, I'm a coder. So in today's episode, I will digitalize my journaling process. Basically, I want to code a small app in C that asks me questions and I answer them. And then it stores my answers. So what's the point of this? Basically, this is just an app for myself. You can, of course, also use it. But I found that when I write down questions to myself, for example, is there one decision I'm avoiding that would simplify everything? Or what would make today objectively successful by 6 p.m.? Something like that. When you reflect on these questions in the morning or during lunch or even after work, at any time during your day, depending on the time, you could actually vary the questions. If you answer those questions for yourself, then somehow they guide your focus and they allow you to focus on the right things during your day. And I found that this is an incredible aid during my day-to-day work. So when I start my work in the morning, I first answer a couple of super important guiding questions, and then I block a focus session and go after what's bugging me, what I just found out in the journal about myself. And then somehow, within 1 or 2 hours, or even after... Oh God, what's going on with the camera now? Wait. Now it's working. Okay. So... So within basically 1 hour or 2 hours after journaling, or even 20 minutes after journaling, you will have made so much more progress than without it. It's an awesome help. So let's go ahead and create something. Let's create a directory, journal, C or C journal. C journal. It's a weird name. I really don't like when apps have the programming language in the name. It's like calling a browser C Firefox or C Chrome. Somehow it's weird. Journal. Journal. Okay, let's just call it journal. Now, in this directory, let's create a small file. And because this is an app just for myself, I don't want anyone raise any red coding flags in the comments. Usually you complain about weird decisions I make, and this time I'm really going to make them. I don't care. For example, we're going to include standard IO, but because oh wait, I don't even know if we have to use standard IO. Do we have to use standard IO? Probably. We're going to use standard lib, probably. I don't even know if we're going to use standard lib. What we're going to do is I will do it super simply. This was going to be super simple. I will create a character buffer. This is the answer buffer, and it has a fixed size. Oh, now everybody's going to cry out loud. And that size is going to be a global constant. For example, 100,000. Oh no, he's wasting so much memory. Oh, I can't hear it anymore. I'm going to allocate 100,000 bytes in my function, and nobody can do anything about it. So this is 100 kilobytes of space here. This is the space that's going to contain my answers. And then as a first thing when launching the program, I'm going to zero out that buffer. So basically, currently this buffer has random contents or uninitialized contents. I'm going to zero it out. We can create our own function, or we can use a new one. I'm not sure if we can use memset for that. I think, yeah, fill memory with a constant byte. So we could use that to fill our buffer for with this character here for n times. Yeah, it's probably the simplest thing to do. And where's memset defined? It's defined in string.h. Okay, then let's go ahead and do string.h here. And then let's create a function, reset buffer or clear buffer. And this is then this new function. Function that returns nothing. Function name is clear buffer. Input argument is nothing because we're going to act on the global buffer. And then I'm going to memset the buffer size, to value 0 size times. Okay, so basically we have now space for 100,000 characters. Who's going to journal for 100,000 characters for a single question? If you have to journal, if your journal answer is 100,000 characters, and you complain about the fact that you can't type more here because this is a buffer of a restricted size, then you have a completely different problem. All right. So, I mean, you have a completely different problem that's not related to programming. So if you complain about the buffer being too small, then go see your therapist. Then we clear a buffer here. Now we, what do we do now? We ask the user a question. Ask question 1. What are the questions? Now I could technically hard code the questions. And what are we going to do here? Ask question. And is this going to be a function? I don't know. We could just printf a question. I'm not sure if I should hard code the question or whether we should read the questions from somewhere. But I think for a start, I mean, I have a couple of favorite questions here in my journal. And I'm going to just pick them. I mean, if I want to change the questions, I can just change them in the code. No, he's hard coding stuff. You need to write the questions into a database. Use a, what's there? What kind of databases are there? I don't know. No, but one thing that we're going to do is we're going to persist the answers to the questions, maybe along with the questions, somehow in some file, such that whenever the user opens the journal, then the old answers are printed out. Or maybe they are not printed out, but they are persisted for the future, such that they can be inspected using a text editor or a file reader. Okay, so we're going to ask a question. We have a couple of questions. Which questions do we have? Character, question, array. Oh. Oh, I'm not sure, by the way, if I can do something like this. I have, for example, 5 questions. So this is 5 questions, each has a length of whatever 1000. And then can I just write questions here like this? This would be interesting to know. Probably it's possible. As long as these, as the questions are smaller than that. But they're definitely smaller than 1000. So if I have 5 questions and each is 1000 characters, maybe I should do buffer 1005 like this, because this is a character buffer of 1000 spaces and we have 5 of those. Okay. So this is the episode where I'm just going to hard code assumptions about string lengths. And I'm not going to care about it because we live in 2026 right now. And this means that we don't have to optimize every single byte. So what's the first question? The first question, let me just pick it from my journal. What did I write down here? There are a couple of questions that are quite interesting. I don't want to code too many here. So, okay, question number 1. If I could finish one meaningful thing today, what would it be? Question number 2. What one skill or knowledge area can I improve today that will compound for months or even years? Next question. Oh, that's a big one. Which mental clutter or outdated assumption can I clear today? So now I have 3 questions. Let's find 2 more. Here, that's a good one. What is one tangible artifact I can create for myself? So basically, this is something that you create during the day. For example, a small script that takes some load off your shoulders, that improves something, maybe an alias in your bash RC. Something small that will add long-term leverage to your life. And then the last question, what will try to hijack my day, and how will I block it? Okay, so this is an array. Technically, we could even simplify that. I don't need this nested array thing, and I'm probably messing it up anyways. So this is now an array of strings. This is weird. What if I just add my own delimiter somehow between the entries of the array? What if I just create a single string like this? This is the questions string. Now let's find all the commas, and I somehow just delimit them. Oops. Somehow I just delimit them with some unusual character. For example, let's just make this all a single string. And these questions are delimited by by this vertical line. Maybe that's not a bad idea. And I don't even need to put a space around the vertical line. I can just concatenate everything directly. So just like this, Let's search the next question mark, delete all of those, vertical line. Search, question mark, delete all of those, vertical line. Basically, also the goal of today's episode is for myself to not try to over-engineer everything, because in the past I would have tried to somehow create some kind of nested array or array of arrays where each string somehow has the right length, all are properly zeroed out. I actually like this. I actually want to try a pragmatic approach here. So we now have a buffer, that's the user's input buffer, and then we have a questions buffer here. And we don't even need to explicitly state a length here. Possibly. We could just keep this a character pointer, questions, and this would point to the read-only section in the program's executable. This would also be possible, but let's just keep it an array. I recently asked ChatGPT about when to use pointers generally and when to use arrays, especially in the context of strings, because they are so similar. You can basically swap them out everywhere. And ChatGPT answered that you use you use arrays whenever you own the data, and whenever you don't own the data and it's allocated somewhere else, for example, by some library, then you use a pointer. So whenever you own the data, usually an array is the most pragmatic way forward. So let's try to ask a question. There's a function now, and we're going to ask questions here in this function. And the function is basically taking in this questions array, it's splitting this up, or it's printing out the question until it encounters the vertical line here. And then it stores the index and then prints out the next question until the next vertical line. How about that? That's quite nice. So all we'd have to do is we'd have to create a static counter or index variable inside this method, because this is a variable that is only used inside, and it starts with 0. Well, how do we even use static variables inside methods? I've never done it. Let's try and see. See static variable inside a function, of course, function. We're not doing anything object oriented. This is the experimentation episode today, guys. I'm going to try all the stuff that I haven't used before. So, the static variable is initialized only once, and further definitions of static variables would be bypassed during runtime. Okay, so I can just write index 0 here, and then whenever the function is called again, then it just ignores this declaration. That's interesting. Very unusual, actually, to me. So now we ask a question. While we read characters from the questions buffer, while questions at this index are equal to, are not equal to the character vertical line. I don't know if I have to delimit it, if I have to escape it, I mean, using the backslash. No, probably not. That was highlighted red. I think that's fine. So while until the vertical line is encountered, and questions. And after the string, we will encounter a null byte. No, okay, we need to check for the vertical line and for the null byte. So I cannot increment in here, because if I increment the index, then it will try to access the wrong index at questions here. So, and questions index. But actually I can probably increment it here. This is not as legible, but it's probably okay. And this last character cannot be \0. Cannot be the 0 terminating character. Then inside this loop, we print f. There's probably a much nicer way to do this, by the way. We print f every single character. Is that really? Forget about it. We print f every single character. Print f character questions at index. But the index is incremented here. That's not so good. Let's remove it. Let's increment the index inside the loop. We print f the character. If a vertical line is encountered, then we print f a new line. Okay. Let's go ahead and go into journaling and into the journal directory. Let's try to compile it for the first time after 22 minutes. Sorry guys, somehow I talked too much in this episode. Then journal input file is journal.c, and that should suffice. And there are a couple of errors. For example, of course, the index has no data type. And what else? I forgot a semicolon after printf. Yeah, I knew something looked odd here. And now if I compile this, there's no more error. And let's check what should happen if we execute it now. The buffer should be cleared. That's fine. So nothing will be visible to the user. And then we will print the first question. That's what ask question does. And then when we ask another question, we should be printing the next question. So let's try. Journal. If I could finish one meaningful thing today, what would it be? So it's really printing the question. That's awesome. Guys, I'm not even sure, by the way, if it ever happened that I just coded something. I just produced code from my fingertips and it just worked. Okay, I fixed a couple of syntax errors, but overall it works. Okay, now the interesting part comes. If I ask question another time, will it print the same question? Or will it print the next question? Because my understanding is that it will print the next question. Let's try. Compile and journal. And this doesn't work. Okay, it doesn't work, guys. This doesn't work. Why doesn't this work? Oh, and now it's getting interesting. So this is something where we could look into a debugger. No, I know why. Because the index is incremented. No, wait. The first ask question terminates the loop when the current index is the vertical line. Then, if the loop is terminated, it doesn't increment the index anymore. So when I ask another question, then the current index will still point at the vertical line here, and the function will not even enter the loop. So what we have to do is, even when we encounter this, even when we encounter the vertical line, we have to increment the index. And let's compile this and try again. And now it's printing 2 questions. Awesome. And what if I do this a couple more times? We should be able to do it 5 times. So this should work just fine. Let's see. Compile and execute. Now this is printing all the questions. If we print one more question, I'm not sure what happens, honestly. Yeah, it will just print a blank. Why is it printing a blank? Well, because the rest of the array is empty, but it could also print anything because the content of this questions array beyond what we filled here manually is undefined. All right, but so far I'm happy with the result. One thing that we could do is we could check how many questions there are. And how do we know that? We know through counting the vertical lines. So, how many questions are there? Then the program knows how often the user can be asked something. Then let's create a variable, question count, that equals 0 at first. And let's create a new method here. Integer count questions. And this returns only the number of vertical lines in the questions buffer. So all we can do, or what we can do, is we can just go over size of questions and do so we loop over the entire buffer. No, that's wrong. That's wrong, because we should only loop over the actual contents of this buffer. Because if we loop up to size of questions, it will loop through all 1,000 characters that are possible, and maybe by accident there will be a vertical line just because it has a random content beyond the string. So we shouldn't do that. We should do a while loop. While loop and while. And now again, we have to loop over everything until this happens. So let me just copy this from the previous code. The questions index is not the same as questions at index are not 0. And then inside here, so basically we start at the beginning. We have a counter variable. In this case, it can be just a function-specific non-static variable. Index is 0 at first. We can increment it inside, probably. No, let's not do it. Let's not do it just for the sake of simplicity and just to avoid bugs. So, how many questions are there? If questions at index is equal to the vertical line, then then the count is incremented. Of course, we first need a count variable here. Count is incremented. And then at the end of this, we return the count, not 0, the count. Let's try and see if this works. Let's print, let's assign question count the value, the return value of the count questions function. So this is now calling this function. And inside this main function, let's print f the question count. Question count like this, and let's see how many questions are detected. So new compilation and new execution. And I think we have an infinite loop because this didn't return. Oh, that's dangerous. What's going on? Let's just try again. Okay, no. Let's just check if this is an infinite loop. This is always quite interesting to me. If we go to the system monitor or task manager in Windows, it doesn't really matter. And we go to resources here and we check the CPU usage, and let's run the journaling app and let's see what happens. Yeah, as you can see, the CPU usage really spikes. It spikes a lot, and that is because this is because we have created some bug somewhere. And as soon as I terminate this app, let's switch back to the system monitor, you can see that the power consumption is dropping again. Yeah, so bugs really consume real energy. It's tangible. But what is the infinite loop here? What's the issue? So questions of course, I forgot to increment the index. So it was a simple one. I need to do index plus plus. Yeah. Okay. And now we can compile and execute again. Now it tells us that we have 4 questions, which is wrong. Because we have 5 questions, as you can see. 1, 2, 3, 4, 5. That is probably because the first question only has a trailing vertical line, but all questions have a trailing vertical line, but the last question doesn't have one. So we should probably assume that we have at least 1 question. So the question counter should start at 1. And let's compile and execute. Now it tells us we have 5 questions and it asks us all the questions. Now, of course, it asks us exactly 5 questions because I am calling those functions here manually. Now we can do a while loop or a for loop. Should be a for loop or a while loop. No, a for loop because we know exactly the count of questions available. So let's do a for loop, question count. So we count from 0 up to the question count. Oops. And inside that for loop, we should ask a question. So let's try. Now the output should still be exactly the same. Oh, I need to declare this integer I first. The output should still be exactly the same as before. Right, but now it's automated through this for loop. And now we ask a question and the user can now answer the question. How can the user answer the question? We just write a function, answer question. And this answer question function works very simply by reading user input. How do we read user input? There are multiple ways. I think a good one is fscanf. We can use fscanf and read from standard in. Right, fscanf reads data from some stream, and standard in, that is the thing that the user types into in the terminal, is basically a stream. No, it's not basically a stream, it is a stream. And then do we even need a format string? Yeah, a simple one probably. Okay, what we do is, let's just try it. We fscanf from standard in. As you can see, standard in is already highlighted yellow. That is because standard in is a file pointer, as you can see here, defined in standard.io. And in fscanf, a file pointer is expected. So this is basically a globally available file pointer that is predefined. And now we read a string. So the format string is just %s or percentage. It's not a percentage character. In this case, it's a format specifier. And the string that we want to store this in an answer buffer. Now everybody is going to cry out again because I'm going to hardcode the size of this answer buffer. And I'm just going to let the user, I know we already have this buffer here, of course. So I'm just going to use the globally available buffer. Why can we use this? Because it's not explicitly written out, but because we use the format specifier for a string, we can use a string variable here that the function will then fill. Let's see. Now, the journaling app still prints the number of questions. I don't want this. I find it annoying. So let's clear everything, recompile, re-execute. So if I could finish one meaningful thing today, what would it be? For example, create myself a small script that automates something, or that automates, for example, in my case, I don't know, YouTube uploads. Enter. Oh, and I think it looks okay because it seems like my answer was taken in and now all the other questions are dumped to the terminal. I don't know why it just dumps the other questions, honestly. So we ask a question, then we answer a question. Maybe this buffer should not be global, but it should be a function local buffer instead. Because we're going to answer the question here. We're going to read it from the user. And let's just printf, just to be sure, you just answered this. And then let's pass the buffer here. Oh, buffer is undeclared. Why is it undeclared? I mean, it's declared here. Ah, of course, because memset uses it somewhere else. Memset uses it up here. We clear the buffer now, not here in the main function, but inside the answer question function, which clears the buffer. And let's just give this the buffer as an input, because otherwise the clear buffer cannot access it, because the buffer is now a method, a function local variable. So this takes now a character pointer. Here we use a character pointer because the function doesn't own the buffer. Let's see. Compile and execute. Test. You just answered test. What one skill or knowledge area can I improve today? Another answer here. You just answered another. So somehow it skipped over the rest of my answer. And it automatically somehow assumed that I already answered the other questions with the rest of the words. Another answer here. Oh, that's definitely not what we want. But why is this happening? We answer a question. We create a buffer. We clear the buffer. We fscanf the buffer. This is quite interesting. So I would expect fscanf to read the entire string. from standard in. But maybe this has something to do with flushing. No. You just answered buffer. This is very, very interesting to me. So we apparently read in only single word answers. This is definitely not what we want. Why is this happening? fscanf accepts a full string. The end of the string should be a new line. Maybe that's what's missing. What happens if I do this? This is the first answer. No, this seems to still be answering every single question with just one word of the scanned string. This is crazy. Why is this happening? So, are we properly clearing the buffer? I think so. Is there anything that we're doing wrong? I think so. But what is it? Is reading from standard in really the best thing here? I would think so, because the user enters his data via standard in. Why are the strings delimited by spaces? Let's just check this. scanf reads only to white space. A format string %s specifier in fscanf skips any white space on the input, then reads a string of non-white space characters. What? Is that even part of the documentation? What if I search for white space here? No space. It is impossible to accurately know how many characters this function has consumed, blah, 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 blah. The new line space, but not the letter. Okay, no, that's not what I meant. These functions make it difficult to distinguish new lines from other white space. Oh, this is even a caveat. This is especially problematic with line buffered input like the standard input stream. Okay, so I just by accident picked exactly the function that we shouldn't use. These functions can't report errors after the last non-suppressed conversion specification. Okay, but then what should I do instead? I just thought that this was the best function to do this. Of course. Oh my god. There's a function fgetS which gets the entire string. Holy crap! Why have I not thought of this? Of course, there's a function fgetS that reads an entire string of a certain size from a certain stream. So we first specify the buffer, then the size, then the stream. Let's just try this. fgetS, then the buffer, then the size, then, forgot it already, the stream, standard in. Okay, and now let's see what happens now. I like the simplicity of the project because it really allows me to learn and it expands my knowledge. Because instead of focusing on really huge problems like getting some geometric functions working in some 3D game engine that I'm coding in C from scratch or something like that, I can really focus on the stupid, simple little C things like strings and sharpen my knowledge there, which is awesome. That's exactly why I code these things in my free time, because you can just learn stuff here. Okay, so code a small script is the first answer. You answered code a small script. Now it's asking me the second question. I don't know, why did it put a space there? Okay, let's try with the second answer. What one skill or knowledge area can I improve today that will compound for months or even years? String handling in C. Pragmatic string handling based on hard-coded buffer sizes. Okay, and it properly gets the answer here. Okay, so let's just answer this one. Last one, hopefully. No, this is the last one. This is the last one. Okay, so the journaling app now asks us all 5 questions that are part of the questions buffer up here. And it terminates after all the questions are done. Now, the last question is that the last thing that we need to do is we need to store our answers, or maybe even the questions and answers, in some log file, in some journaling log file. So you can ask a question, or we ask a question. I'm not sure if we should really store all the questions and answers, but I'm inclined to do it because if you change the questions one day, then you don't have to somehow migrate the database. You can just keep a log of the strings of the questions, answers, questions, answers, questions, answers, questions, answers. When you change the questions, eventually, then they will just be appended to the log. It's just a simple text file. No need for fancy engineering here. So here, let's print, instead of you just answered, you answered. And in front of the question, let's print, and I think even this printing the questions character by character is totally stupid. If there's fgetS, then there's also fputS probably. Of course there is. Which prints an entire string. However, it prints an entire string, yeah. So we could refactor the code to print strings from a starting address, which is this constant character pointer here, up to the next null terminating character. Oh, actually, instead of the vertical line, we could just use null terminating characters. But after all, I find it quite nice if the null terminating character signals the end of all questions, so we don't have any null terminators between the questions. No, let's keep it like that. Let's just keep it super pragmatic, and the question before each question, let's just print f and print question colon space close the command, and let's see how this looks like now. So now it prints question, blah 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 blah. You answer something, it stores the answer. Question, blah blah blah. You answer something else, it stores the answer. Okay, so this now works interactively. Now we just need to store. What we have asked, or what the program has asked, and what we have answered. So how do we do it? You answered this, print f. We print something, but then we also print it to some file, fprintf. So let's store the result in some file pointer. But that's a side effect of the method. That's not so nice. You should only answer the question in this function here. Maybe we should return the answer, but no, then we have to somehow pass the character buffers around, which is horrible. That's not good. I want to keep this as simple as possible. So that's probably fprintf. It must be as simple as possible. You answered. So basically we type the same thing as below, as above, this. And we fprintf to some file pointer. So that's the journal file. File pointer, journal file. So and this function reads the user answer and stores it in the given file. Okay, this could work. And now we just need to create some file here. We just need to give this main function, or we just need to create a file pointer in this main function here. So we open a file for writing. Man fopen. So this opens a file. We just specify the path and a mode. The mode is write only. Fopen. What's the path? The path is the current directory. Journal log. And the mode is write only. Let's just confirm this here. The mode is a constant character pointer, so it's a string, yes. And write. Oh, and we don't want to truncate the file. If we write something into the journal, we want to append. So maybe we need to, yeah, we need to open for appending. To write, we want to open at the end of the file. The file is created if it does not exist. So this is perfect. This is exactly what we want. And this returns a file pointer, journal file. Then we ask questions. And we ask a question and store it in the journal file. And then we answer a question and store it in the journal file. So we ask something, we store it. We answer something, we store it. Same thing for the question. But here we have a totally disintegrated question. We're just printing the question like this. It's horrible. But if we want to align it with the appending to the journal log, then we can just fprintf the same thing to the journal file. Oh my God, forgive me guys, forgive me. All the C gods, forgive me. And I don't mean you guys in the comments, I mean the gods of C that are in heaven, floating around and punishing the people who are hard coding buffer sizes and doing this shit right here. Then file pointer, journal file. Okay, and it could be, if everything is correct, that this now works. Okay. To please the sea gods, I'm going to close the journal file. Whenever we open something, we have to close it and see. And let's see what happens. I always find it funny when I'm coding something in C and then I keep saying, let's see what happens. Okay, let's see. And I said it again. If I could finish one meaningful thing today, what would it be? A meaningful thing, of course. I want to learn Python, mental clutter, search for a new job, girlfriend. No, that's just a joke. Family, country, planet. No, not plant. Ah, damn it. What is one tangible artifact that I can create for myself? Python script to rule the world. What will try to hijack my day and how will I block it? Well, TikTok. I will block time and focus. Okay, now I have completed the journal. Let's see, was a file created? Yes, there's a journal.log file. Let's have a look. Maybe a binary file seed anyways. Oh my god. Why is it a binary file? What the hell did I write into it? This looks like I wrote the functions. This looks like I wrote the program's own memory into the file. What? What did I do? Probably it's up here. I want to write into the journal file. Just to be sure, let's have a look at the fprintf documentation. Fprintf here. Okay, first argument is a file stream, then the format string, and then the variable. So, and that's exactly what we're doing. Then probably, one thing that I also need to fprintf is this new line down here. But aside from that, what could I be doing wrong? I mean, it looks like I'm really dumping the program's own memory into the journal. Remove journal. And this is something that would really be simpler in other programming languages. Compile. Too many arguments. Oh, of course. Let's search for the new line. Search / new line. There it is. Compile, execute. Okay, let me just type something here. Okay, and now if I look at the journal, journal.log, it worked now. Did it just work because I added a new line, fprintf? It's crazy that when you forget such a small thing that the output is varied so much. Or maybe I messed up something else. I have no idea. If you know it, then just put it in the comments. And now it would make sense to also store the time at which the user submitted this journal. And this should be the first thing that the user submits. So here we open the journal file and then we store the time in the journal file. Store time. So because we of course want to know, if we create a digital journal, then we want to know the history of our edits, right? I want to know that on the 1st January I entered this, then on the 1st June I entered this, on the 30th August I entered this, etc. And maybe also the times at which I entered stuff are quite interesting. If you do everything over a long run, you could extract quite a bit of data by just adding the time as an additional item that is stored. So we can store the time here. How do we store the time? we store the time to a journal file, just as with the other methods. And then let's create a new method down here. Function store time in the file pointer journal file. And then inside that function, what do we do here? We get the current time. And I remember in one of my last episodes or one of my last couple months ago, where we coded an analog clock, we already did something similar. If you want to find out how to code an analog clock with a graphical user interface in C, then have a look at that. It's quite interesting. I liked how times work in computers. Times are really interesting in C and in computers in general, because you have just seconds since a certain date, and then you have to somehow convert them. And it's not trivial, because you have sometimes you have leap seconds, then you have leap days, then you have leap whatever, and you can't even determine when a leap second happens, because it's really complex as far as I know. And then you have the time zones, which mess everything up. It's crazy. So times are a huge rabbit hole. As far as I know, there's the ctime function here that takes as input a constant time pointer. This is basically just returning a string as a formatted time value. So we want to get, and now we use a character pointer, because this data is not created by us, it's created by this library function. That is exactly what I meant earlier. This is the time string, and it's produced by ctime of a current time value. How do we get the current time value? We get it from man time. No, that's a bash command. Man 3 time maybe. Yeah, that's it. Time t time. And if we pass null here, then it should get the current time. Right, if tlock, which is this input argument, is a null pointer, no value is stored. Right, okay. Yeah, already forgot that one. So this one returns the current time, and it returns it via two ways. I don't know why this is being done like this, but either you get the time as a return value, or you get the time via a pointer that you provide, and then the function fills that value for you. Maybe it's just a convenience thing. I don't know. So we can just create our own time variable like this. Time t, time equals time. Maybe we shouldn't call the variable the same name as the function. I don't even know if this works in C, if this is legal. Probably it's not legal, but one thing that we know now is that we have to include time.h, because that's where this library function is defined, and that's where we got this warning from. And now inside this, let's call this the time value, something like that. And let's see if this works. Unused variable time string. Oh yeah. And here we're passing argument 1 of ctime makes pointer from integer without a cast. Of course, we want ctime to... ctime needs a pointer as an input. So we need to do this. We need to use the ampersand operator to get the address of this variable. Now we just get a warning about an unused variable. This is not going to be unused for long, because now we're going to store it. And we're going to store it by printing it using fprintf. Let's just fprintf it to the file directly and not printf it to the terminal. I mean, the user knows which time he's currently working on. Yeah, working in, whatever. Fprintf, we provide, or we write into the journal file, we write time of submission, or just time time is good enough. The string, new line, and then the argument is the time string. Okay. By the way, do we have to free this character pointer somehow? Because ctime certainly, well, it returns a pointer, so, and this pointer was created by ctime, so where do we have to free it? Free. Is there a code example here? ctime. The call ctime is equivalent to ASCII time or ASC time local time. It converts the calendar time into a null terminated string of the form this. This is perfect. Yeah. Okay. Let's forget about these micro optimizations. I mean, should I free it or not? This is literally just 12 bytes of memory or something like that, and it's not going to cause a memory overflow because the application is running and then closing, and whenever the application or the process exits, then the memory is freed anyways. So time to compile and see what happens. Now let's remove the journal.log and start from a fresh directory state, compile and execute the journal. So I want to code some Python script. I don't know. What one skill can I want to improve my boxing. Which mental clutter or outdated assumption can I clear today? Witches don't exist anymore. This is my outdated assumption. What is one tangible artifact that I can create for myself? Let's say a bash script that makes my laundry. And what will try to hijack my day and how will I block it? My dog. How will I block it? I didn't even answer that because I won't block it. So, and if we now inspect the journal.log, we have, right, this means it's working. So we have a time that's being logged, and now we have the answers here. Perfect. And that's it. So if we now call the journal again on the next day and we enter something here again, for example, today I want to finish my Finnish lessons. What's one skill on it? Let's just write something here. Democracy is very nice. What's one tangible artifact that I can create for myself? A sword. Sword would be a very tangible asset for myself. What will try to hijack my day and how will I block it? I don't know. Okay, and let's see. Now, if everything has worked out, then we should have 2 sections of journal entries now, because the journal is now a dynamically updating log file. Whenever we enter something, the journal is updated. So let's check the journal.log file. And as you can see, we have now 2 entries, time here and time here. This means the project is working exactly as I wanted. And now, of course, I entered funny answers here just to make you laugh. But it's really meant for myself and potentially for you as well to answer seriously, reflect on how I do it. Is I set a timer to 10 to 15 minutes, and then I really think what I need to do, what things I want to improve. I really think and contemplate the answers, and then they force me into the right direction and really ensure that my day is awesome. That project was quite fun. You can now make so many improvements here. You can improve the formatting of the stored data, of course. You can add compression. You can store the stuff in a real database. You can do whatever. But for me, this is a nice rolling, appending log of journal entries that I can keep forever in the future. And if we just compress this with, for example, zip or something, or tar gzip, then this would be a super small file because it's just text. So let's not overcomplicate stuff. Guys, if you like this simple lesson or this simple episode today, then leave a like and subscribe. And if you want to learn C just as we do on all the other videos on this channel, if you wanted to learn it from the ground up, then have a look at the No Nonsense C programming course. It's a course that takes you from zero C knowledge to a very capable C programmer, such that you can follow and understand all the videos from start to finish without any problems. So for any practical C stuff that is not over-optimized, not academic, just gets things done as we did in this video, have a look at the course in the description down below. And I'm looking forward to seeing you in the next episode. Bye-bye.